In this example problem, we're going to use the same exact data sets that we just used to compute the expected average annual earnings of a Euphoria State College post-graduation. But now, instead of pinpointing an exact dollar amount, we're going to give ourselves a little leeway by constructing a 95% confidence interval based upon this regression. So we're going to come up with a range of future earnings that we expect a Euphoria State College graduate to earn, that we are 95% confident that once we have all of the information of the entire population, that the true population mean will lie between. The easiest way to do this, in my opinion, is to modify your regression analysis. So instead of just posting a dollar amount, like this is the average cost of St. Ambrose, this is the average cost of Albion College, this is the average cost of Alfred, where my uncle graduated from. We are going to instead change those inputs. So instead of just being a fixed dollar amount, it's going to be how far away it is from Euphoria State's inputs. So for St. Ambrose, we can say right here that our modified regression for average annual cost, well, St. Ambrose costs $22,920 a year, while Euphoria State costs $25,000. And I'm going to want a fill handle, so let's make Euphoria State College's reference absolute. There we go. And what we can say right here is, instead of St. Ambrose costing $22,920 a year, let's rephrase it to say that it costs $2,080 less than Euphoria State College a year. And we're going to do that for all of the inputs. So for St. Ambrose, that institution has a 62% graduation rate. Well, what is Euphoria State's College? It's 60%. Again, I want to make Euphoria State's information absolute. So I can rephrase that to say that St. Ambrose College has a 2% higher graduation rate than Euphoria State does. Continuing on down the line, St. Ambrose College has 88% of their graduates pay off their debts after graduation. That exceeds the 80% that we have for Euphoria State, make that absolute, by 8%. So St. Ambrose's, let me make this a little bigger for all you guys so you can see, there we go. St. Ambrose, in this case, has an 8% higher percentage of their graduates paying off their debt than Euphoria State does. And then lastly, in this case, we've got our modified regression for city or rural. Well, St. Ambrose, because it has a 1 in our binary variable, is in a city area. So is Euphoria State, and I want to make Euphoria State absolute as well, which means there is no difference from that. They're exactly the same inputs. And why I made all of Euphoria State's inputs absolute and not the other colleges is because I wanted to do this. I'm just going to double click down in the corner for all of these, and it's going to give me my modified regression. And for each school out of this list of 116, we have how much more or less it costs on average than Euphoria State, how the graduation rate differs from Euphoria State's, how the percent of past graduates who are paying off their debt differs from Euphoria State's, and how the city-rural binary variable differs from Euphoria State. And now, with all of this information in here, we can do another regression analysis comparing average post-college earnings to our modified inputs that we have over here. So I'm going to go back to the data analysis tool under data. I still want to do regression. My Y range is the thing we're testing for. We're still trying to find a confidence interval in this case based upon the expected average annual postgraduate earnings of Euphoria State graduates. So I still want my Y column to be the output I'm looking for, the average post-college earnings of all of these schools. But my input range now, instead of using the raw numbers that we have listed over here, I want to use all of the modified things that we put in. I want to use everything in column G through J. And I want to grab all of those inputs, so I'm going to hit Control-Shift down, and I have everything from G1 to J117. I put the labels in there, so let's turn the label thing on. Scrolling back up, where do I want to put this? What is my output range? Well, let's put it just a couple of spots below. If I can click on that cell, below where we're looking for the information, I'm going to pick cell L13 in this case. And I'm going to hit OK. And after I do, it's going to make me my summary output. Let me scroll on over so we can look at the numbers. There we go. I'm going to do the same thing I did before, go to the coefficient column, and I'm going to change it to dollar amounts just so it's easier to express in terms of dollars. And what we have here is an intercept, the baseline, and then a slope for all of the 4 factors that we had that we said could influence postgraduate earnings. Well, because we modified our regression and we made it the difference from what Euphoria State has for all of these columns, what this information is saying is that for every additional, in this case, dollar that an institution costs more than Euphoria State, graduates will earn an additional 43 cents. For every 1% graduation rate higher than Euphoria State, graduates of an institution will earn $178.10, so on and so forth. But here's the catch, and this is why I converted it. All of these are for how something differs from Euphoria State. Well, we're not looking for the information from, say, Elmhurst College over here in row 28. We're looking for a confidence interval for Euphoria State. And that makes Euphoria State our baseline, what I have highlighted here. What this information right now is saying is that a Euphoria State graduate can expect, on average, to earn $45,408.80. Switching back over to the tab that we did previously, you can see now it's the same number that we had before. And with that, that's our predicted output of X. That is our X bar. So now I can go through and I can figure out, in this case, what my confidence interval is going to be based upon that Y hat. I'm sorry, I didn't mean X bar. That Y hat, with the predicted earnings that we have for Euphoria State graduate. What is our T critical in this case? Because we're going to need that for our confidence interval. Well, how you're going to find your T critical in this case is you're going to use the T inversion function, just like we did before. So I'm going to go to insert function. I'm going to type in t.inv. I'm going to hit go. And it's one-tailed, so I'm just going to hit OK on that. I'm asked for my 2 inputs. And the first input I'm asked for is the probability. Just like before, if we're 95% confident that we're not going to make a type 1 error, we're 5% not confident. And of that 5%, half of the time it's because it's going to be too low, and half of the time it's going to be too high, the tails. Well, we're doing a one-tail test right here, so we want the probability of just one, of not appearing in one tail. So 95% plus half of what's outside of that gives us 97.5%. I'm going to put in 0.975. And now we got our degrees of freedom. And this is going to be a little bit different than what we had before. We've been doing one variable tests for all sorts of inputs that we've had when you were doing hypothesis testing, etc. And it was always n-1 for degrees of freedom. Well, now we have not 1, but 4 different inputs that we used when we were determining our regression, these 4 modified regressions that we had up above. So when you are doing finding a t-value for a regression that has a lot of different inputs, the formula isn't n-1, it's n minus k minus 1, with k being the number of different inputs that you are testing for. So let's figure it out. We have a sample, as we know, of 116 colleges. We tested for 4 different explanatory variables in this case. So our k would be 4, so 116 minus 4, and then minus 1 because it's minus 1. 116 minus 4 minus 1 is 111, which you'll see is listed over here in our ANOVA area. That is the residual that we have there, cell M25 in this case. And we want that to be equal to 1.9816. That's going to be the t-value that we're going to use in our calculations. Now, with that, I can just fill in these formulas. We have y hat minus t critical times SE with T critical and SE in parentheses. Well, we know our T critical. We know our Y hat. It's right here. It's the expected earnings that we have for a Euphoria State graduate. What is the SE, the standard error that we have for Euphoria State graduates? That's right next door. That guy is right here. We're saying that the standard error that we have is $1,017.28. So I can just fill in that formula. The lower limit of our interval is going to be equal to our Y hat, our predicted earnings for Euphoria State, minus, in parentheses, that T critical times our standard error. And that comes out to $43,392.99. For the upper limit of our interval, I'm going to take that same Y hat, our predicted earnings for a Euphoria State graduate, plus, in parentheses, our T critical, which we determined to be 1.9816, times that same standard error of $1,017.28. Close that parenthesis, hit enter, and I come up with an answer of $47,424.61. So what this all means is we can say with a 95% confidence, if we are this guidance counselor that is looking for information right here, that a graduate of Euphoria State College is going to earn somewhere between $43,392.99 and $47,424.61 in their first year upon graduation.